Welcome to part 5 in our 6-part series looking at Science 9, Outcome 9B4. This time we are looking in more detail at molecular and ionic compounds. The specific outcome. Students will assemble or draw simple models of molecular and ionic compounds. For example, toothpicks, peas, and cubes of potato. Introduction. Understanding how atoms combine to form compounds is a fundamental part of chemistry. One way to make this concept more accessible is by assembling or drawing simple models of molecular and ionic compounds. These models help us visualize the relative positions of atoms within a compound, making abstract ideas more concrete. In this section or video, we will explore how to construct and interpret these models using everyday materials such as toothpicks, peas, and cubes of potato. We will also discuss the differences between molecular and ionic compounds and why it is important to show the arrangement of atoms rather than their orbital structures. The orbital structures get very complicated and are left for later grades. So atoms are the basic building blocks of matter. When atoms join together, they form compounds. There are two main types of compounds, molecular and ionic. Molecular compounds are formed when atoms share electrons, creating molecules. Ionic compounds are formed when atoms transfer electrons, resulting in positive and negative ions that attract each other. For example, water is a molecular compound with the formula H2O, meaning it contains 2 hydrogen atoms and 1 oxygen atom. Table salt or sodium chloride is an ionic compound with the formula NaCl, made up of sodium ions, Na+, and chloride ions, Cl-. So why use models? Models are useful because they help us see how atoms are arranged in a compound. By using simple materials, we can build models that show the relative positions of atoms. This makes it easier to understand how compounds are formed and how their properties depend on their structure. At the grade 9 level, we're just going to focus on the arrangement of atoms, not the details of their electron orbitals. Orbital diagrams are more advanced. They are not required at this stage. Instead, we use models that show atoms as spheres or shapes connected by sticks or lines to represent bonds. Materials for building models. You can use a variety of materials to build models of compounds. Some common choices include toothpicks. They represent bonds between atoms. Peas. These can represent small atoms, such as hydrogen. Cubes of potato would represent larger atoms, like carbon or oxygen. Clay or Play-Doh can be shaped into spheres for different atoms. Colored beads can help distinguish between different types of atoms. So you can actually buy some model kits that'll have a variety of colors the same size as well as a variety of sizes. The key is to use materials that are easy to handle and can be connected to show the structure of the compound. So let's look at building molecular models. We'll start with molecular compounds. These are made up of molecules, which are groups of atoms held together by covalent bonds or shared electrons. For example, water. To build a model of water, use a cube of potato to represent the oxygen atom, use 2 peas to represent the hydrogen atoms, and connect each hydrogen atom to the oxygen atom with a toothpick showing the bonds. Arrange the atoms so that the hydrogen atoms are not directly opposite each other. The water molecule makes a bit of a V shape. In reality, the angle between the hydrogen atoms in water is about 104.5 degrees. But for a simple model, just make sure they're not in a straight line. Let's look at another example, carbon dioxide. For this, we use a cube of potato for the carbon atom. We use 2 cubes of potato for the oxygen atoms. Make them different sized cubes so you can distinguish between carbon and oxygen. Connect each oxygen atom to the carbon atom with 2 toothpicks, representing the double bonds. That 2 minus in oxygen says it wants to connect to 2 other electrons. Carbon likes to have 4 electrons shared, so it shares 2 with oxygen and vice versa. Arrange the atoms in a straight line because carbon dioxide is a linear molecule, meaning it looks like it's in a line. Building ionic models. Ionic compounds are made up of ions, which are atoms that have gained or lost electrons. These ions are held together by electrostatic attraction. To build a model of sodium chloride, use a P for the sodium ion. Use a cube of potato for the chloride ion. Place the ions next to each other, showing that they are attracted to each other. In reality, sodium chloride forms a crystal lattice with each sodium ion surrounded by chloride ions and vice versa. For a simple model, you can arrange several P's and cubes in a checkerboard pattern to show the repeating structure. Drawing the models. If you do not have materials to build models, you could draw them instead. Use circles to represent atoms and lines to represent bonds. Label each atom with its chemical symbol. H for hydrogen, O for oxygen, and so on. For molecular compounds, draw the atoms connected by lines showing the shape of the molecule. For ionic compounds, draw the ions next to each other, indicating their charges. So here are some examples of these. Upper left, we have oxygen. There's 2 sticks there because it likes to go 2 minus. Each atom wants to share 2 electrons. So they each share 2 electrons with each other. Carbon dioxide, we go for 4. That black carbon atom in the middle has 4 bonds, or 4 sticks coming out. The red oxygens have 2 each. Water, H2O. There's that V shape with the 104.5 degree angle between them. Table salt, sodium chloride. They tend to be adjacent to each other. The bonds tend to be a lot weaker. Glucose is more complicated. We have almost a hexagonal ring on the bottom with carbons at the corners and hydrogens coming out, except one of the carbons in the ring is replaced with an oxygen. And that carbon goes up and connects to a hydrogen there. So the importance of the relative positions. When building or drawing models, it is important to show the relative positions of atoms. That means where they are compared to each other, because in a real world, the molecules tend to be free to turn around and move. This helps understand the shape of the molecule or the structure of the compound. The properties of a compound often depend on its structure. For example, the bent shape of water molecules give water its unique properties, while the lattice structure of sodium chloride makes it a solid at room temperature. In conclusion, assembling or drawing simple models of molecular and ionic compounds is a valuable way to learn about chemistry. By using everyday materials or simple drawings, you can visualize how atoms are arranged in compounds. Remember to focus on the relative positions of atoms and do not worry about orbital structures at this grade level. These models will help you understand the basics of chemical bonding and the structure of matter, laying the foundation for more advanced studies in chemistry. Let's check for understanding. Which of the following is a common method for representing molecular compounds in a model? Using metal rods and screws, using paper and glue, using sand and water, or using toothpicks and marshmallows. Pause now if you need more time. Toothpicks and marshmallows would be a simple way. What do the toothpicks represent in a molecular model made with toothpicks and peas? Are they atoms, bonds, electrons, or neutrons? Pause now if you need more time. They represent bonds. When constructing a model of an ionic compound, what do the different colored peas typically represent? Are they different types of atoms, bonds, ions, or molecules? Pause now if you need more time. The different P's are different types of ions. In a model of a carbon compound, how many bonds should each carbon atom typically form? 2, 3, 4, or 5? Pause now if you need more time. Looking at the group carbon belongs in on the periodic table, it typically forms 4 bonds. Which of the following best describes the difference between molecular and ionic compound models? Molecular models are always larger than ionic. Molecular models show sharing electrons while ionic show transferring electrons. Molecular show transfer while ionic models show sharing. And molecular models use only one type of atom while ionic models use multiple types. Pause now if you need more time. Molecular models share electrons, ionic models transfer. If you have questions, comments, or feedback from this lesson, please leave it in the comments. I get email notifications and will try to respond in a timely fashion.